Okay, then I have here business math, financial mathematics examples. So this is linear programming using graphic method. So you have here two kinds of product, chainsaw and clipper, chipper. So the chainsaw is X, the chipper is Y. And then the hours are 3 and 6. The profit for the chainsaw is 150 and chipper is 220. Then we are trying to maximize this profit. The maximum available is you have only 330. The numbers are less or equal to 30 and the hours are 120 or less. So that is maximize z equals 150x plus 220y. Subject is the constraint is x plus y has to be less or equal to 30 and 3x plus 6y has to be less or equal to 120. Then x, of course, x and y are greater than 0. So you draw this region, the feasibility region. So you have the x plus y is this curve and the 3x plus 6y is this curve. So the feasibility region is, so this is below the curve, that means this is the visible region. Above the x-axis to the right of the y-axis, so this is feasibility region. So we know this corner point is 0, 0. This corner point is 0, 20. This corner point is 20, 10. This corner point is 30, 0. So you identify the corner points, then you simply plug those corner points into the objective function, which is the maximizing function, z equals 150x plus 220. So when you plug 0, you get 0. When you plug 0, 20, you get 4,400. When you plug 20, 10, you will end up with 5,200. When you plug 30, 0, you will end up 4,500. So that means the maximum you will get is 5,200, and that is when you have 20, x equals 20, which is chainsaw is 20, and chipper is 10, which is y. Okay. So I have this another example, product exchange. So this is product exchange between gasoline and the hidden oil, and the relationship between them is y equals 125,000 minus 25x over 125 plus 2x. So to find the maximum gasoline, you set the y equal to 0, which is the x-intercept. So y is 0, so you set the numerator equal to 0. So that's x equals 5,000, that is the maximum gasoline. Then to find the maximum oil, you set the x equal to 0, that's the y-intercept, and that is 1,000. Simply you put x equal to 0. Then if the gasoline is 125, you put that into the that's a formula, the equation, then you will end up with oil is also 215, which is this is when they are equal. Okay. Then here I have an example of feature value of compounded interest. So a developer needs 80,000 to buy land. So he is able to borrow the money at 10% per year compounded quarterly. How much will be the interest? So to find that, basically the compounded interest formula is A equals P times 1 plus I to the n. You use this formula, you will end up with A equals the feature value is $131,089.32, and the interest is 51,000. So you can use this formula, or you can also use TVM solver in TI-84. You simply put the numbers. So n is, you put the n with the I, then simply you come here, you do the alpha solve, it will give you the solution. Then number 15 is also an ordinary annuity. A typical packet day smoker in Ohio spends about $170 per month on cigarette. Suppose the smoker invested that amount at the end of each month. That means the smoker quits smoking and puts this into an investment that gives 5.3% compounded monthly. What would be the amount in 4 years? So you can use this formula. This is S is the feature value of the ordinary annuity. R is what you put into the annuity. In this case, it's 170. Then times 1 plus I to the n minus 1 over I. So if you do that formula, the smoker, if that smoker quits smoking and put that money into the account in 4 years, that smoker will have 280,686. That is the feature value of that annuity, and of course the health on top of that. So you can confirm this using TVM solver TI-84. So you just plug the numbers and do alpha solver, you get the solution. Then I have another ordinary annuity payments application. This time we are going to figure out how much payment you have to make. So this is John Smith will purchase 300,000 home with a 25-year mortgage. So if he makes down payment 25%, then how much he should put? Well, the interest is 2.9% compounded monthly. What will be the monthly payment? So you use this formula. The present value equals of annuity is R times 1 minus 1 plus I to the minus n over I. So then that will give you R equals PI over that. Then you use this formula to calculate. The monthly payment will be 1,055. Confirm your answer using financial TVM solver. You can use TVM solver also. Basically, you put the information, alpha solve, will give you this value. Then I have here an application of matrix input-output analysis of economics. You have two economic basic products, wheat and oil, and the relationship between them is, this is the matrix relationship between them. A, an input-output matrix, 0.5, 0.16, 0.66, 0.22. The demand function is 750 for the wheat and 1,500 for the oil. So you do the TI solver, you can use I minus A all inverse D. If you do that, which is in identity 2 minus A in TI calculator, identity 2 minus A inverse D, you will end up with this solution. That means for this to meet this demand, you should have the wheat X is 2,901 and the oil y, which is 4378.